talked about many times that all cells need oxygen in order to break down glucose. Cells can partially break down glucose without it. That pathway is called glycolysis, where glucose is converted into pyruvate. Okay? But you only generate just a little bit of ATP, just 2 molecules of ATP through glycolysis. In order to extract the full complement of ATP that you need from glucose, that pyruvate molecule then has to enter into the mitochondria and pass through a pathway called the Krebs cycle. Now, that pathway requires oxygen. As a result of the Krebs cycle activity, instead of generating only 2 molecules of ATP from each glucose, with the Krebs cycle, with the use of oxygen, you can generate about 36 molecules. So it's much more efficient. Now, at the same time you're using oxygen to break down glucose and extract ATP, you're also generating some waste products, which include water and CO2. So the cells have to have some way to get rid of that excess CO2. Okay? And that's part of the role of the respiratory system. So the respiratory system is going to supply cells with oxygen, at the same time get rid of or excrete the CO2 that's being generated. And so it does it through 4 processes. Number 1 is pulmonary ventilation. Pulmonary ventilation is very, very simple. It's just movement of air into and out of the lungs. Nothing more, nothing less. So if I ask the definition of ventilation, it's just movement of air into and out of the lungs. Now, once air moves into the lungs, okay, it carries with it oxygen into the alveoli. The alveoli are the little sacs, air sacs within the lungs. Okay? Oxygen then moves across the linings, the membrane of the alveoli, into the surrounding pulmonary capillary blood. At the same time oxygen is moving from the alveoli into the bloodstream, CO2 is moving in the opposite direction. It's moving from the pulmonary capillary bloodstream into the alveolar sacs. So there's an exchange of gases that occurs at the level of the alveolus. That's referred to as external respiration. Okay? So with external respiration, pulmonary capillaries are filling up with oxygen and getting rid of CO2. The next part of the process involves then transportation of gases. The movement of that blood, which is now loaded with oxygen, to tissues. At the side of the tissues, that oxygen is unloaded. That's called internal respiration. At the same time, those capillaries within the tissues are picking up CO2 to return to the lung. So that exchange of gases that occurs at the level of the tissues is called internal respiration. The exchange of gases that occurs at the level of the alveoli, that's external. Okay. But again, all these processes simply serve the function of providing the body with oxygen and disposing of CO2. Here's a picture of the respiratory system here. Okay. It starts with the nose. You know, we have a saying in the biz. It's the nose, nose. Nose, nose. So air is going to enter into the respiratory tract. These little, I don't know if you've ever seen, there's 2 little openings near the tip of your nose. Have you all noticed that before? What are those called?
Nostrils.
Yeah, that's what most people call them. Nostrils, right.
Okay.
External nares. Singular would be nares. Those are the external nares. And by the way, you'll notice that they're crisscrossed. Has anyone looked closely into their nose, like in the bathroom? Y'all do that?
Yeah.
Okay. Well, you know, it's nice that someone does that.
I mean, you gotta check.
You gotta check, right. So if you notice closely, do you notice that there are some hairs, coarse hairs that are kind of crisscrossing the entrance to those external areas, Alyssa?
Yeah.
In your nose? Okay.
You just-
What do you think those coarse hairs are doing? What are they doing? They're filtering, you're right, they're filtering the inspired air, right. So even at the very inlet into the respiratory tract, you begin to filter the inspired air. Now, that air is then going to pass from the nose into the nasal cavity, and then it's going to reach the pharynx. Pharynx is another name for the throat. And the pharynx is going to have three divisions. The part that's behind the nasal cavity is called the nasopharynx. That's spelled N-A-S-O, not nasal. One word, nasopharynx. Below the nasopharynx, if we continue down, is the oropharynx, spelled O-R-O pharynx. And then finally, if you keep coming down the pharynx, the inferiormost aspect is called the laryngopharynx. Partly because it leads into the larynx, which is the voice box, but it'll also lead into the esophagus, which sits behind the voice box. Okay. So then air is going to pass into the larynx. Okay. It'll pass through the vocal cords here, and then into the windpipe, but we don't call it the windpipe. What do we call it? Trachea. Trachea. Now, if we come down the trachea, there's a point at which the trachea bifurcates. There's a special name for that site of bifurcation. It's called the carina. Nothing could be finer than to be at the carina in the morning. Carina. C-A-R-I-N-A. So if you ever watch a bronchoscope being performed, you know, you'll look at a television screen as the pulmonologist is passing the fiber optoscope, and as it reaches the bifurcation, he says, okay, we're at the carina. And that's simply the site where the trachea bifurcates. And then when it bifurcates, air is going to flow either into the right or left primary bronchus. You can call it primary or alternately main stem bronchus. So the right main stem bronchus is going to deliver air to the right lung, the left main stem to the left lung. And these primary bronchi subdivide like the branches of a tree into one generation, then another. So they lead into secondary bronchi, which then lead into tertiary bronchi. And you have multiple divisions of the bronchi. Now, the smallest bronchi are referred to as bronchioles. Bronchioles. And then ultimately the bronchioles give rise to the air sacs. Which, what do we call the air sacs?
Alveoli.
Alveoli. And that's where external respiration occurs. So that's kind of the sequence in which air moves. We're going to take it back a step and start from the get-go, the nasal cavity. The nasal cavity is separated from the oral cavity by the palate. Okay, so the palate is kind of a shelf that separates the nasal cavity above from the oral cavity below. And you'll notice that the anterior two-thirds of that shelf is supported by bone. It's hard to the touch. So if you take your finger and touch the anterior two-thirds of the palate, it feels hard. So we refer to this part as the hard palate. But if we extend our finger further back, okay, we'll notice that if the palate loses its bony support, it becomes the soft palate. Okay. And at the very back of the soft palate, there's a little fleshy finger-like extension that hangs down. What do we call that little fleshy finger-like extensions.
Uvula.
Uvula. Uvula. You know, it's a funny thing. If you ever watched cartoons as a kid, and they showed a cartoon character screaming, they'd do a close-up of the mouth, and you'd see the uvula moving back and forth. Do y'all remember that?
Uh-huh.
Yeah. All right. And you might say, well, what the heck is the purpose of that uvula? Like, what is it doing down there? You know, there's actually a rhyme and a reason. When we swallow, the uvula moves up and helps to block off, for instance, the nasopharynx, so that food and beverage don't go up into your nose. Okay? So that's one of the major roles of the uvula, is to tilt upward with swallowing to protect your nasopharynx and your nose. Couple picture here. Okay. The nasal cavity is subdivided by a partition. What do we call this partition? Nasal septum. It subdivides the cavity into a right and a left half. Okay? Now, on each side, projecting into each side of the nasal cavity, are these scroll-like structures. You remember what these are called?
Concha.
Either conchi or turbinates.
What do you say?
So this would be the superior nasal concha, or a better term is turbinate. This would be middle. And this would be inferior on either side. And of course, the same mucous membrane that surrounds the nasal septum is going to surround the conchi, the turbinates. In fact, this same respiratory mucosa that covers the nasal cavity is going to cover most of the airways within the respiratory tract. Okay? What type of epithelium does it contain? Pseudostratified columnar. Ciliated pseudostratified columnar epithelium is the classic respiratory epithelium. So much so that we simply call it a respiratory epithelium. It covers most of the respiratory system. Okay? Now, along the roof of the nasal cavity, in addition to having a pseudostratified columnar epithelium, this epithelium is embedded with olfactory receptors. Okay? So we call this part along the roof an olfactory mucosa. An olfactory mucosa. But the rest is unmodified respiratory epithelium. Ciliated pseudostratified columnar epithelium. Okay? And remember that the pseudostratified columnar epithelium has goblet cells. And the purpose of the goblet cells is to produce mucus. Now, in addition to this mucosa possessing goblet cells, there are also glands that are deep to the epithelium, okay, within the submucosa. So, as a result of the goblet cells and these other glands that are deep to the epithelium, this surface mucosa is covered by a layer of sticky mucus. Okay? So one of the functions of not only the nasal cavity, but also the entire respiratory tract is to filter inspired air. Okay? So it's filtration. And one of the ways it does it, in addition to having vibrissae, those coarse hairs at the entrance, is by trapping debris and bacteria and smoke or whatever else is suspended in that air along this mucus lining, because it's very, very sticky. Okay? So that mucus will trap material that's suspended within the inspired air. Okay? And this, remember that mucus is sitting on top of cilia. And the cilia are going to propel that dirt-laden mucus into the back of the pharynx, where we swallow and get rid of it. Okay? So if dirt or debris is trapped within a nasal cavity, that material is swept backwards. If it's trapped within a trachea, that material is swept up. In fact, for that reason, we refer to this combination of mucus and cilia as a mucociliary either elevator or escalator. So filtration, cleaning inspired air, is a very important role in the respiratory tract. Now, this mucosa here within the nasal cavity is very, very vascular, meaning it has a high density of capillaries. Okay? And all of that warmth being brought into the mucosa allows you to warm up inspired air as it passes through the nasal cavity, as it passes along the surface of the turbinates. So that's another function of the nasal cavity, is to warm inspired air. It plays a role in olfaction. We said that the olfactory mucosa along the roof has receptors for smell. And then the nasal cavity serves as a resonating chamber for speech. In fact, you'll notice if someone's nose is all clogged up, their voice sounds a little bit different. I'm going to show you something here. There are 4 sets of paranasal sinuses. And these paranasal sinuses all drain into the nasal cavity.